Algebra 1, Unit 8, Day 1. This unit is all about miscellaneous functions and things that you can do with functions, mainly transformations. So the first kind of function we're going to deal with in this unit is called a piecewise defined function, or just piecewise function. And a piecewise function is really just what the name sounds like, is it's a function that's made up of pieces of other functions glued together. You can read the paragraph about the more in-depth detail of what that really means. But if you take a look at this graph, there are actually three different pieces of different functions put together, and this we're going to call as one function. So they are calling the function f of x down here. So f of x is equal to, and they have three different equations, and of course the color of the equation is the color that it corresponds to on the graph. So the blue piece is a line, and it's the line x plus 2, but instead of graphing the whole line, we're just graphing the part where x values are less than or equal to a negative 1. Once the x values go past negative 1, we don't graph that line anymore. The next piece is 1, so remember f of x is a fancy way of saying y. So on the blue piece it was y equals x plus 2. On the second piece it is y equals 1, which is the red piece, a little horizontal piece. And y equals 1, remember, is a Hoy line, and it's going to be horizontal. Well, you're going to graph the piece of that horizontal line starting from negative 1 and ending at positive 1. And then the third piece is y equals x squared, which is a parabola. But instead of graphing the entire parabola, we're only going to graph the part starting with x values of 1 and going to greater x values, and that's the part that you see up there in green. Now, as you know, mathematicians like to be efficient, so instead of writing y equals 3 times or f equals 3 times, they're going to write the f of x once and say that it's equal to all of this stuff under these conditions over here on the right. We've got the people at MathBits who put this together did a really good job of trying to show you where that graph comes from. So if you were to graph the line y equals x plus 2, as shown in the box labeled number 1, you would get that entire line. But because it said from x less than or equal to negative 1, they're showing you with the dotted rectangle that they're cutting out the portion of the graph where the x values are less than or equal to negative 1, and then they're putting it down here. The next piece was y equals 1. We said it was a Hoy-Vux line, so it's a Hoy. You get the entire horizontal red line, but they only wanted the pieces from negative 1 to positive 1, so that's where they're showing the dotted rectangle to cut that out, and they put that part of the graph here. And then the third piece was the parabola y equals x squared, graphed in green, but they only wanted the piece where x was greater than or equal to negative 1, so they cut out the part of the graph that had x values from 1 up, and they put that over here. And then they showed you where they glued the graph paper together, and that's how they got the graph with the red, the green, and the blue on it. Now, we aren't going to physically be cutting our graphs apart and gluing them together. That would take forever, so we're going to learn how to do it with our graphing calculator. There are two ways to define piecewise graphs. They are either continuous or they're discontinuous. Discontinuous functions are when, like say for this example, I traced over my entire function. When I get to here, I cannot get to the blue part of my graph without picking up my pencil. That's discontinuous. That example that we were just looking at above here, I can start at the left and trace over that entire function without picking up my pencil. That's called continuous. Alright, so here's some more examples, and they have them all color-coded, which I think was really cool. We're going to start off by evaluating them, and I think the next lesson is the graphic. So It's a very popular kind of question. So the function is defined with these pieces. One piece is that 3x minus 5, and the other piece is x squared. And on the right side right here is where the conditions are. And that's what we really want to focus on. So when it says find f of 7, we know 7 is the input, so 7 is the x value. You're only ever going to fill it into one of the pieces. You never fill it into more than one piece. So what you need to do first is to figure out what piece it belongs in. And that's where you look at the conditions on the right. So the top condition says that the x value has to be greater than 4. Well, our x value is 7, and since 7 is greater than 4, that tells me to plug the 7 into this piece. So I get 3 times 7 minus 5, and now I just do what it says. That gives me 16. Alright, so for number 2, it says evaluate f of 4. So 4 is my input, my x value. If I go check the first condition, it says x has to be greater than 4. Is 4 greater than 4? No, so it does not fit that condition. I go check the next one. Is 4 less than or equal to 4? Well, yeah, it's equal to 4. So that means I take my 4 and I plug it into the second piece. So I get 4 squared, which is 16. Third example says evaluate f of negative 3. So go check your conditions. Is negative 3 greater than 4? No. Is negative 3 less than or equal to 4? Yes. So we're going to take that negative 3 and plug it into the bottom piece. Negative 3 squared makes 9. Number 2. More of the same, except this time our function has 3 pieces. Again, you will never plug it in to more than one piece. So evaluate f of negative 2. Our x value, our input, is negative 2. Check the conditions. Is negative 2 less than 3? Yes, it is. So we're going to plug it into that piece. We have a negative x, that's where I put my negative 2, minus 4. The double negative becomes a positive. Final answer is negative 2. Next one, evaluate f of 12. So our x value is 12. Check the first condition. Is 12 less than 3? No. Second condition says between 3 and 10. Nope. Is 12 greater than 10? Yes. So we're filling the 12 in for the third piece. 120 divided by 12 plus 5 gives us an answer of 15. Excuse me, f of 10. So 10 is our x value. Is 10 less than 3? No. Now, this says between 3 and 10, but you need to look at the inequalities. These inequalities both have equal signs, which means the 3 and the 10 are included in this piece. So since 10 is equal to 10, we are filling it into the second piece. 10 squared minus 7 makes 93. And then f of 6. Is 6 less than 3? No. Is it between 3 and 10? Yes. So we're plugging it into the second piece. 6 squared minus 7 makes 29. Alright, evaluating from the graph. Alright, again, these are all inputs. That makes them all x values. So we just need to go find the point that has that x value on it. So we're looking for an x value of negative 2. So here's my negative 2, and this point right here has an x value of negative 2. So my answer is the y value that goes with it. Next, they want f of 0. Now this is a special case. 0 has this point, which is an open circle, and this point also has an x value of 0, but it's a closed circle. And if you remember way back from when we did inequalities, we learned that open circles are just boundaries and they don't actually count. So I don't want this point at the origin. I'm going to use the one that has the closed circle and say that my answer is 2. Next one's f of 3, and we have that same situation again. We have an open circle that has an x value of 3. We have a closed-in circle with an x value of 3. Only the closed circles count, so my answer is 2. That's the y value. Alright, f of 5. Here's the point that has an x value of 5, and its y value is negative 1. Number 4, start purple. F of negative 2. So we need an x value of negative 2. This point has an x value of negative 2. Its y value is 4. F of 0. Here's a point with an x value of 0. Its y value is also 0. F of 1. Here's a closed point for a 1 and an open point for 1. Only the closed ones count, so the y value is 1. And f of 2, we have an open circle that's not going to count, a closed circle that will, so our answer would be 3. Okay, there are some homework problems that you can try on your own now.